Welcome back, Stella. In the previous video, we saw the different types of projectile motion. We basically saw that there were two principal types: vertically upward projection and vertically downward projection. And in each of the cases, we saw the different two types. Now, in this video, we're going to see how to choose and orient the origin of reference of a projectile, because it is very important. When I'm talking of choosing and orienting the origin of reference, it is to mark your I and J vectors with your origin. Will it be in this direction? Will it be in this direction? Or in any other direction? So that's what I'm talking of. This is a very important step, whether it is in projectile or when solving a mechanics problem. It is a very important step. If you don't orient your origin of reference, you will always make errors of signs. So it is very important. So to do that, the first thing you have to do whenever you have to orient your origin of reference is to, first of all, the first thing you have to do is to determine the direction of motion, of the particle. That's why in the previous video I taught you how to know if the particle is moving, the motion is upward or the motion is downward. You first need, when they give you an exercise, I told you that in physics, whenever they give you an exercise, bring out the data, you draw your diagram. After drawing your diagram, if you are in mechanics, you have to mention the direction of motion. The second thing, it is after mentioning the direction of motion, from there that you can start choosing and orienting the origin of reference. It is this thing that I call the origin of reference. Is that okay? Now, in some exercises, I first want you to understand something. In some exercises, they can precise the origin of reference. They can precise the origin of reference. First of all, so we are going to study, in this video, we are going to study, let me go back a minute. In this video, we are going to study the previous types of projections we saw. This vertically upward type, this. We're going to know how to precise the origin of reference here, and we are going also to learn how to precise the origin of reference here for the vertically downward projection. Is that okay? So that will be our objective here. Now, you should understand something. In an exercise, if no information is given telling you that take this point as the origin of reference, always take as the origin of reference the point where the particle is starting the motion. This is an advice I'm giving you. If no information is set, that take as maybe the floor as the point, take the floor, like for example, they can say an object is projected from a height h and it describes a projectile motion. Take origin of reference as the floor. It means that when you would draw your diagram, they say an object is projected vertically upward from a height. So if I have to draw it, for example, they say an object is projected vertically upward. So if this is my floor, it is projected vertically upward from a height h. I'll first represent my vertical height. This is my vertical height h. Is that okay? The object is projected from this height, so this is the diagram. Is that okay? The object is projected, they said, vertically upward from this height, so this will be the diagram. So your velocity u will be here, and this is your angle alpha. Now, if they say take as origin of reference the floor, it means that you are going to come here, mark this point 0, and this will be your j vector, and this, the particle is, the first thing you have to do is what? represent your direction of motion. The direction of motion is how? Upward. So my positive j vector will be in this direction and my I vector will be in this direction. Now, let's say in the exercise, it is instead said, take as origin of reference the point where the particle is being projected. That means the first thing, you know that it was projected vertically downward, vertically upward. You precise your direction of motion, and from there, you come at this point. They said, take as origin of reference the point where the particle is being projected. You come here, the particle is going, so this is, the motion is upward. So my positive y, my positive j will be in this direction, and my negative, and my plus I will be in this direction. Is that okay? So take note of that. And I said, if in an exercise nothing is said, like for example, let's take this situation. They say a particle is projected from a height h above the floor vertically upward. So if it is projected from a height h, this is your h, projected vertically upward. So this will be the diagram. Is that okay? This is your direction of motion. And in the exercise, it is not said that take a certain point as origin of reference. I told you, when no information is given about the origin of reference, about which point you should take as origin of reference, always take the point from where the particle is projected as the origin of reference. Always take that point as the point, as the origin of reference. Always take that point as the origin of reference. If they precise that, take the floor as the origin of reference, then you will come here, mark your O here, then you look at your direction of motion, you mark your positive J in the upward direction and your I in this direction. Is that okay? So we shall take each of the cases and try to simulate some situations. It is very important for you to understand this. Very, very important. It is very important. So let's dive into, we shall study each of the projectile motions and simulate situations. So let's first take, let me wipe this. Let's first take the first case. So I said, when you want to represent, when you want to choose and orient your origin of reference, it is very important that you first determine what? The direction of motion of the particle. It is very important. After determining it, the question you have to ask yourself, has an information be given as the on the point as you take as origin of reference, or has no information be given? If no information is given, then you should take what? The point where the particle starts the motion as the origin of reference. If an information is given, then take that information that is given as the point of origin of reference. Is that okay? So take note of that. So we shall study each of the projectile motion. The first one, vertically upward projection. The case of vertically upward projection. We saw that in vertically upward projection, there are basically what? Two types. We have vertically upward projection from the floor and vertically upward projection from a height. So let's take the first type. The first type, vertically upward projection from the floor. Is that okay? Vertically upward projection from the floor. So I'll draw my floor. This is my floor. This is my floor. Is that okay? This is my floor. Let me draw a vertical axis like this. The particle is being projected like this. Is that okay? The particle is projected like this. So this is your velocity. The particle, vertically upward projection from the floor. This is the floor. The particle is projected like this with velocity u. This is the angle alpha. the first thing we have to do, generally in this type of projection where a particle is projected from the floor, the origin of reference will always be what? The point from where the particle is projected, because there is no other point where uh, 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 it's true. In an exercise they can also decide as, they can say that take as origin of reference. Let's say there's a certain point H here. They can tell you that take this point H, where this point A, as origin of reference. So take note, be very careful. So in this case, I said generally in this situation, the origin of reference will always be taken as what? The point where the particle is being projected. So the first thing you have to do is what? Identify the direction of motion. The particle is projected how? It is moving like this. So the motion is what? Vertically upward. This is the direction of motion. That's the direction of motion. Is that okay? When I know already my direction of motion, this will be my O. Is that okay? Because it's projected from the floor. So let's take this floor as origin, as O. Now the positive direction is the direction of motion is like this. So everything upward will be positive. Everything upward will be positive. So this will be my positive J, and the vector here in this direction will be what? Let me take a blue pen. So this will be my positive J, and this will be what? My I vector. Is that okay? So that's how you orient your origin of reference in this case. Is that okay? Now let's move to the other case, vertically upward projection from a height h above the floor. Vertically upward projection from, so sub to vertically upward projection, upward projection from a height h above the floor, from a height h above the floor. Okay, in this case we are going to have two situations. The first situation is where the origin of reference can be at the floor, and the second situation is where the origin of reference can be where? At the level where the particle is being projected. Is that okay? So let me draw this first diagram. So this is my floor. Wait a minute. So let me wipe this. A minute. Let me wipe this. So this is my floor. This is my floor. This is my floor. The particle is projected at a certain height h. This is the height h. Is that okay? I'll draw this other horizontal. It is projected vertically upward. So this will be the trajectory it will describe. Is that okay? This is your velocity u, your initial velocity, making an angle what? Alpha with this horizontal. Is that okay? Now I said there are two cases. Let me draw. This will be small a, this will be small b. Let me draw. This is the floor. This is our floor. Our particle is projected at a certain height h from the floor. So our floor is down here. This is the floor. So the particle is projected vertically upward. Let me extend this line first of all. Projected vertically upward. So that's its trajectory. So we have velocity u making an angle what? Alpha with the horizontal. Now I told you there are two conditions here. There are two situations here. The first situation can be a situation if you are in such a situation in an exercise. Let me give you an advice. If you are if you are in such a situation in an exercise where the particle is projected vertically upward from a height h above the floor, the advice I'll always give you, if no information is given, if no information is given about, if no information is given on the point from which, on the point you should take as origin of reference, always take the point where the particle starts the motion as the origin of reference. So if we are in a situation, let's say we are in a situation where nothing was said about the point you should take as origin of reference. So what I would take, I personally, as origin of reference will be the point where it is projected. So I'll come here. First of all, you have to determine your direction of motion is what? This is the direction of motion because the particle is moving upward. This is the direction of motion. Is that okay? So if nothing is said about the point you should take as origin of reference in the exercise, you take the point where the particle is being, the point where, this is where the particle starts the motion. So I'll come here, I'll call this point 0. Don't forget that this is h. I'll call this point 0, the origin. The motion is how? Vertically upward. So my positive j vector will be like this, and my positive I vector will be how? Like this. Is that okay? If in an exercise, it is said that take the floor, if in an exercise we are in this situation, if it is instead said take the floor as origin of reference, what I'll do is what? I come here at the floor, I'll come and mark here, I'll put my 0, my origin. The motion is wow, vertically upward. So this will be my j vector, and this will be what? My I vector. Is that okay? From here, what can you understand? When your origin of reference is at this level, anything that will be upward will be what? Positive. And anything downward will be what? Negative. The same thing here. Anything upward here will be positive, and anything below this origin will be what? Negative. Is that okay? So, if in an exercise, you are dealing with a vertically upward projection from a height h, if nothing is said about the point you should take as origin of reference, always take the point where the particles start the motion as what? Origin of reference. But if they say take the floor as origin of reference, then you come and place your what? Your origin of reference here. And the orientation of this j will depend on what? On the direction of motion. Positive j will be oriented in the direction of motion. Is that okay? So take note of this. Take note of that. Let's dive to the other situation. The other situation, because we have seen already vertically. We saw that in vertically upward projection, we have vertically upward projection from the floor, which is this, and vertically upward projection from a height h. So I have already explained how you should choose your origin of reference. Is that okay? In exercises, you should you see that what I'm saying like this is very important. Is very important because depending on where your origin of reference is, things will change in the exercise. So be very careful. So let's move to the next sub 2. We are going to see vertically downward projection. Vertically downward projection. Okay, we have the sub 2, vertically downward projection. Don't bother, in exercises you are going to understand what I'm explaining here better. And this choosing and orienting the origin of reference is very important when you are determining the initial conditions. So we are in vertically downward projection. We saw that in this case there are two types. We have vertically downward projection. We have what? Vertically downward projection when the angle makes an angle what? When the initial velocity makes an angle theta with the horizontal, and the case where the horizontal, the initial velocity is horizontal. So those are the two cases. Okay, let's take the first case, sub 1. Vertically downward projection with velocity with initial velocity making an angle alpha with the horizontal, with the horizontal, with the horizontal. Okay, in this case, we can have two situations. We saw that in these vertically downward projections, generally the particle will be at a certain height. That's it. Is that okay? So in this situation, we're going to have two cases. The first case, A, let me draw my floor. This is my floor. This is my floor. The particle is at a certain height h from the floor. This is our floor. Now let me extend this horizontal line. It is projected what? Vertically downward. So vertically downward. This is how that will be its path. And they said that the velocity is at an angle alpha to the horizontal. So this is our initial velocity u, which makes an angle alpha with the horizontal. Is that okay? The second, so why am I saying that there are two cases here? There are two cases because there is a case where they can ask you to take as what? The point where the particle is projected as origin of reference, or they can ask you to take what? The floor as the origin of reference. Is that okay? So I'll draw this B. This will be the floor. This will be the floor. The particle is at a certain height. At a certain height h. It is at a certain height h from the floor. So let me extend this. It is a vertically downward projection. So this is the trajectory. We have our velocity, we have our velocity u, initial velocity u, which makes an angle alpha with the horizontal. Is that okay? Now, if in an exercise, as I said previously, if no information is given, on which point you should take as origin of reference, what should you do? You take as origin of reference the point where the particle is starting the motion. Where is our particle starting the motion? This point. This is where it is starting the motion. This is where the particle is starting the motion. Is that okay? Now, the first thing, before placing your origin of reference, what should you show? Your direction of motion. The particle is, we analyze the starting point. It is moving like this. So the direction of motion is how? Vertically downward. So this is the direction of motion. Is that okay? Also here, this is the direction of motion. Is that okay? After representing our direction of motion, from there we can represent our origin of reference. So let's say nothing was said about the point you should take as origin of reference. So what I will do is what? I come where the particle starts the motion. I mark a point here. This will be my point O, the point 0, 0. The point O is the point of coordinate 0, 0. Is that okay? Now, from here, I need to know how I will orient my J. Is that okay? How my J vector will be in the direction of motion, because this is the direction of motion. That is the positive direction. So my J will be how? Downward. This is my J. Wait a minute. So this will be my, this will be my J vector, and my I vector will be higher. This will be my I vector. Is that okay? Now, let's say in the exercise, they tell you to take as origin of reference the floor. Let's come and represent it here. This is our direction of motion we have already represented. They said take the floor as origin of reference. So I'll come here. Don't come here. No. The particle is at this level. So I do a projection here. I come exactly where there's the floor. I mark this point. And I will call it what? O. The point of coordinate 0, 0. Is that okay? From there, what is my direction of motion? My direction of motion is downward. So my J will be here. This is my J vector, and my I vector will be how? This is my I vector. So what can you understand after representing this origin of reference? Anything downward like this will be positive, and anything upward like this will be what? Negative, because this is the positive J. So anything like this will be considered positive, and anything like this will be considered what? Negative. Any distance like this will be considered what? Positive, and any distance like this will be considered negative. Is that okay? If we are here, this is our origin of reference. Any distance like this will be considered what? Positive, and any distance upward like this will be considered what? Negative, because this is the origin and J is downward. Is that okay? Take note of this. Take note of this. If in an exercise they tell you, in an exercise where you have vertically downward projection, they tell you take the point H above the floor, take the point where the particle is being projected as the origin of reference, then this is what you are supposed to have. Is that okay? If they say take the floor as the origin of reference, then this is what you are supposed to have. Don't cram this. Understand the logic behind things. Understand the logic behind things. The first thing we do is we determine the direction of motion. Then, if in the exercise nothing is said about which point we should take as origin of reference, we take origin of reference what? The point where the particles start the motion. So, this point. Is that okay? So, take note of this. Take note of this. Don't cram things. Don't cram. Understand the logic behind things. Understand the logic. If you understand the logic behind things, you will always be capable of solving any exercise. Now, the second thing we have to see with vertical downward projection with velocity with velocity horizontal. So the angle between the initial velocity and the horizontal is what? 0. So let me move to the sub 2, small Roman 2 with, so vertical downward projection with initial velocity horizontal, with horizontal initial velocity. Okay, basically here we are still going to have two cases where the origin of reference can be on the floor or where the particle is being projected. Is that okay? So let me draw it. So the first case A, this is our floor. This is our floor. The particle is projected vertically downward, so it will generally be from a certain height h. Is that okay? It will generally be from a certain height h. Is that okay? The particle, let me extend this line. Particle is projected vertically downward, so that will be its trajectory. But they said that what? The velocity is horizontal, so our u vector is in this direction. Is that okay? Perfect. We draw another one, B. This is our floor. This is our floor. Is that okay? The particle being projected vertically downward, it will always be from a certain height. Is that okay? From a certain height h, certain height h. Let me extend this horizontal line. It is projected vertically downward, so the trajectory will be that. They said that the velocity is what? The initial velocity is horizontal, so this is our initial velocity. Is that okay? Now, having represented that, if they tell you that, you see that the angle between the velocity here and the horizontal is what? 0, because the velocity is horizontal. Is that okay? Now, if in the exercise, if you are given such an exercise, as I said previously, if nothing is said about the point you should take as origin of reference, the first thing we have to do first of all is to what? Show the direction of motion. The particle is what? We analyze from the starting point. It is moving what? Downward. So this is the direction of motion. Is that okay? The same thing here. This will be the direction of motion. Is that okay? Now, after representing the direction of motion, let's say no information was given about which point you should take as origin of reference. What should you do? You take the point where the particles start the motion as origin of reference. So we are in, let's come for example here. This is where the particle starts its motion. So I'll mark this point and I'll call it what? O. O, which is the point with coordinate 0, 0, the origin. Is that okay? From there, I'll I'll look at my direction of motion. How is my direction of motion? It is going downward. So my J My positive j will be like this, and my I will leave it like this. Is that okay? My I'll leave it like this. Is that okay? If in the exercise it is instead said that, take the floor as origin of reference. If we take the floor as origin of reference, what I wish, here is where the particle is starting. So I come directly under here. Here is the floor. I'll mark this point, call it what? O, which represents what? The point, the origin, the point of coordinate 0, 0. From there, I'll look at the direction of motion. The direction of motion says that what? The downward direction is positive. So my J, I'll orient it like this, and my I, I'll put it like this. Is that okay? So that means basically means what? Anything, any distance that will start from this 0 downward like this will be what? Positive. And any distance upward like this will be what? Negative. Is that okay? The next thing, if this is our origin of reference, it means that any distance, because this is the origin, J is downward, any distance downward like this will be what? Positive. And any distance upward like this will be what? Negative. So take note of how you orient your origin of reference. Look at this video twice or thrice to master everything that I said. So when you are in an exercise, the first thing you have to what? I said you have to do what? To determine, the first thing you have to do is to what? Determine your direction of motion. After determining your direction of motion, you have, and drawing your diagram, you have to ask yourself which question. Has an information been given on the point where I should take as origin of reference? If no information is given, then I take which point? The point where the particle starts the motion as the origin of reference, and I orient my reference. If an information is given, then go at that point where they said you should take as origin of reference, mark your O there, and orient your reference. Is that okay? Look at this video so many times. Master all what I just said. Master well all what I just said. It is a very simple concept. Master everything. If you master all of this, let me tell you that if you master all of this, you will never face problems in mechanics. You will never face problems in mechanics. Whether you will never face problems in projectiles or in mechanics, because the same procedure I just explained now is the same procedure that applies in mechanics. So that was all for this video. Try to go all through the video. In the next video, we are going to see how to determine the initial conditions of a projectile. Because you know that when we're dealing with projectiles, when we come out with the different expressions, the initial conditions are always important. When I'm talking of initial conditions, I talk of what? The initial position and the initial velocity. Is that okay? The initial position, which will have coordinate x0, y0, and the initial velocity, which will have coordinate what? Ux and uy, or v0x or v0y. Is that okay? So go through that video. In the next video, we're going to see how to determine initial conditions of a projectile. So see you in the next video. Take care.